Math 5130. What I'll cover in this video are z-scores, box plots, and the 5-number summary. Here we get into quartiles and stuff. I really hesitate. I didn't know when to bring z-scores in. I guess this is as good as any time. So let's just go over these pretty quickly. And again, if it's been a while in z-scores and you need more in-depth instruction, Khan Academy, other things that Google searches can get there. But a z-score is just a standardized score that tells us or gives us an indication how far from the mean in standard deviations that a score lies. And a positive z-score says that our raw score is above the mean. A negative z-score says that it's below the mean. We typically have these lines in the sand. I'm talking about number 3 here, that a data value is significantly low if its z-score is less than or equal to -2, significantly high if the z-score is greater than or equal to 2. Z-scores, again, are standardized units, and they have no unit of measurement. To give you an indication of an important use of z-scores, I think an important use of z-scores is to compare scores from different distributions. So, when you take blood pressure, your top number and your bottom number, your top number's always going to be higher, your bottom number is going to be lower. You really can't compare those two numbers. But with z-scores, you could, because you expect the top number 120 to be higher than the bottom number 80, but z-scores allow us to compare this. In academic setting, ACTs and SATs are scores that are on different distributions. Z-scores give us a way to actually compare the two. And the illustration I'm going to have here is comparing adult body temperature and IQ scores. So the 99-degree temperature among 106 students or adults, sample mean of 98.2, sample standard deviation 0.62, IQ of 132, sample mean of 100, sample standard deviation of 15. How do these two compare? Well, what you would do is you create the z-score for each one of these. So take 99 minus its mean, divided by its standard deviation, I get 1.29. Take the IQ of 132, subtract the mean, divide by the standard deviation, you get 2.13. So within their distributions, an IQ score of 132 is more extreme because it has a higher z-score than a 99-degree Fahrenheit body temperature. So again, that's what it allows us to do. Now, quartiles are something that kind of, are closely related in a sense to z-scores, but they're a measure of location. And we essentially have 3 quartiles. We have quartile 1, quartile 2, and quartile 3, which divides a data set into 4 equal groups. And you think about it, if you have a string and you want to cut your string into 4 equal pieces, how many cuts do you have to make? Well, you have to make 3 cuts, right, to get 4 pieces of string. And that's essentially what we're doing with our numbers as they're ordered from high to low. So the first quartile separates the bottom 25% with the top 75%. And again, you have to visualize this, that our numbers are sorted from lowest to highest. Q2 is also known as the median, separates the bottom 50% with the top 50%. And Q3 separates the bottom 75% with the top 25%. Now, the cautionary statement, you can put the same data set into different statistical software packages, And sometimes the quartiles will come out different values. It's kind of frustrating, but there's just no really universal agreement on how to calculate these. So different technologies will give different results. So if one of you is using R and one of you is using, SPSS, and you get different results, it doesn't mean really that anybody did anything wrong. It's just the nature of the beast. All right, another thing that we get into a lot is called the interquartile range. That's just Q3 minus Q1. It's abbreviated IQR. Typically, when I statistically describe it, must be important because I'm raising my voice, right? Sorry about that. When I am statistically describing my quantitative variable, in a study, I will report the mean and the median as the measures of center, the range, the high, the low, the standard deviation, and the IQR as the measures of spread. Result of finding the minimum, quartile 1, quartile 2, quartile 3, and the maximum, we call that the 5-number summary. 5-number summary is very easy to find. You really can't, in the statistical software packages that we use, you can't just hit something and it'll spit out the 5-number summary, but you can find the minimum, the maximum, Q1, the median, and Q3, and report those as the 5-number. So just quick illustration. The numbers here are range from low to high. So of the 5 numbers, 2 of them are really easy, the smallest one and the biggest one, which in this case be 23 and 662. Then we'll come to the center. In this case, we have an even number of measurements. So we will find the average of the 2 center. And then we'll find Q1 and Q3. So Q1, that 182, really turns out to be just the median of the data below the median. And 359 turns out to be the median of the data above the median. So the 5-number summary in this case would be 23, 182, 273.5, and so on. Now, once we find the 5-number summary, we can create what's called a box plot. I mentioned this in an earlier video. There are 2 graphs that we typically use to display univariate quantitative data when describing our sample. That's a histogram and a box plot. A box plot displays the 5-number summary and helps us identify outliers. More about that later. So constructing a box plot from the 5-number summary that we just created would look something like this. Notice it's got 1, 2, 3, 4, 5. And this box plot apparently, it's hard to tell, but apparently isn't displaying outliers. I will teach you to create box plots that display outliers using statistical software. But yeah, it looks like this one does not. All right, that's all I got. Next video, I will demonstrate some things with the 5-number summary.